Welcome back. We are getting ready to do the second video on chapter 2. On this video, we still have 5 more objectives to go to finish this chapter, but we are gonna only concentrate on topic number 3. Recognize and work with the SI base units of measurement, prefix multipliers, and derived units. So on the last chapter, on the last chapter, chapter 1, we were talking about the scientific method. And we were saying that one of the parts of the scientific method is to do the experiments. And usually what we do on experiments, we observe before and after situations. And for us to be able to evaluate that, we need to be able to measure something so we can compare. And we measure all the time. That's part of our everyday life. We measure mass, we measure time, we measure length, we measure a lot of other stuff like the speed of wind, the humidity, and so on. And on a daily basis, we probably are measuring volume, everything we drink, everything we eat, and all that kind of stuff. So measurements are all around you. And when we measure, for example, volume, you can go crazy with so many different types of measurements. Volume can be measured as a liter or liters, barrels, cubic centimeters, gallons, cubic foot, bushels, drams, cubic inches, cubic meters. It's just crazy the way there's so many different ways that you can measure volume, for example. The same thing happens with probably surface area. For example, you can measure a square foot, square meters, acres, and yards, and a lot of other stuff like that, or cubic yards and stuff like that. So basically what I'm saying is, when we measure, it's like languages. There's so many ways of talking about the same thing. So if we want to be effective communicating like scientists, we have to come up with a common language. And this common language is what we know the SI system, which is nothing more than for French, System International, which means it's shared by all nations. We agree this is the way we're going to measure so we can understand each other. And some of the basic unit of measurements are going to be length, how long something is, mass, and we measure mass usually with weight, time, and temperature. But, for example, you know that temperature can be measured as degrees Fahrenheit, it can be measured as degrees Celsius, and it can also be measured as Kelvin. So we are agreeing also, not just what we are measuring, but the specific unit that we're going to use. For the SI system, the length is going to be measured in meters, and then we have a symbol so we don't have to write the whole well. The mass is going to be measured as kilograms. And as you notice, you're probably used to grams. So why use kilograms? Well, because when we do this in an international way, most of the time it's for commerce. And when you are transporting something to another country, you're using huge amounts. So we're looking for something that reflects a huge amount. And a kilogram is nothing more than 1,000 times a grams. So we're going to be talking very soon about these prefixes that we're using with our units. And then the System International also tell us that we're gonna be measuring time as seconds, and like I already said, the temperature we're gonna concentrate on the Kelvin unit. So those you should know. That's something you should memorize. So, like I said already, the mass, we measure it in kilograms. So why do we have to use these prefixes? Well, remember we mentioned earlier that we need to be able to measure in astronomy, for example, a galaxy, how many light years across. We can be measuring something at the microscopic level, like a bacteria, or you can even go further down. You can be measuring something at the nano level, like atoms and electrons. So, so nano, micro, and all that kind of stuff, where's that coming from? Well, we know that a galaxy is something close, if I remember right, something close to 10 to the 20 meters. So we can measure straight on scientific notation. So what we're doing is we are taking this scientific power and we are converting it to the units or these prefixes that I'm talking about. For example, nano is going to be 10 to the minus 9. So the scientific notation that we know that we had to use to measure really, really big things and really, really small things, now we're giving it a name. So nano is 10 to the minus 9. Micro, that's what this is called, a microscope, is 10 to the minus 6. And we can use those prefixes, so this will be the one for micro. We can use those prefixes with any unit. It could be microseconds, it could be micrometers, and so on and so on. So this unit is nothing more, or these symbols like nano, macro, kilo, they're just another way to simplify scientific notation. That's all it is. So it's important for us to know the value of these symbols. So this is something that you should also memorize. You should be very familiar with the values of the different prefixes that we're going to be using. For example, tera equals 10 to the 12. And 10 to the 12 means that if I have something that is 3 teragrams, that means that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 grams. Because this is nothing more than teragrams. And that's the symbol that we use. So you should memorize this. Let me show you a quick way to memorize this. So your brain finds a pattern and you don't have to spend so many neurons on it. So let me show you real quick. Let me add another page so I can show that to you. So this is what I like to do. I like to do something dumb or funny like this. To gain memory, no. Basically what I'm saying is to gain memory, no. And then I can also say, doctor, can my microwave nuke potatoes? And what I'm saying is, doctor, can my microwave nuke potatoes? And then you get the pattern. This is 10 to the 12. This is 10 to the minus 12. This is 10 to the 9. This is 10 to the minus 9. This is 10 to the 6. This is 10 to the minus 6. But Hopefully by now you have seen the pattern. It's changing by 3. 10 to the 3, 10 to the minus 3. And then we write the pattern. 10 to the minus 2, 10 to the minus 1. And just right there, you have memorized how to assign the values to the different prefixes. So make sure you learn the name, you learn the symbol, and you learn the value, because those are going to be very important to what we're going to be doing in our next learning objective. And here's your first daily work. Using this table and what you know so far, answer this question: which is the most convenient unit to use to express the dimensions of a polio virus, which is about 2.8 times 10 to the minus 8 meters. So which of these units would be the most appropriate to do that, and how you will write the number? And then explain why you chose that unit and not another one. And let's talk now about derived units. For example, floor plan. When you buy a house, the more square footage it has, the more expensive the house is, because it means that it's bigger. And this is a floor plan of a house, and it tells you that the master suite measures 14 by 15 feet. So as you notice, they're being multiplied. So when you multiply those numbers, whatever that gives you is going to give you a square feet, because you're multiplying 14 feet times 15 feet. And that's what we call the area of that room. And then you can do the deck, you can do the family, and so on. So the square area is going to be given, on this case, on a square feet, which is a derived unit because you're using 2 units to get to that unit. What about the dice? Well, on the dice, we can measure the volume as a derived unit, because we can say, let's say that this measures 2 centimeters, and from here to here it measures 2 more centimeters, and from here to here it measures 2 more centimeters. So the volume is going to be length times width times height. In this case, 2 centimeters times 2 centimeters times 2 centimeters, which equals 8, 3 times to the square of the to the cube of the centimeters. So this is a derived unit volume because you use 1, 2, 3 units. You use more than 1 unit to get to it. What about the density? Imagine a lot of you have probably seen this probably on a school or something like that. And we know that the lower the density, if I have oil and water, we know that the oil will be in top because the oil have a lower density. And density, we can calculate the density by dividing the mass over the volume. So density is a derived unit because you're using 1, 2 units to get to it. So here's your next daily work. Based on this activity that you see in here, a person running on a treadmill, what possible derived units can you measure on that situation? What units you're gonna need to measure that situation. For example, density, you use mass and volume to find the density. So what would you need on this case? And with that, we can say hopefully that you grasp already the concept that we're discussing here, which is the system international base units, which are mass is kilograms, temperature is Kelvin, time is second, and volume is cubic meters. The prefixes, and you have to memorize the base units, and the prefixes, which are gonna be the ones that we use to substitute the powers on the scientific notation. Tera is 10 to the 12, pico is 10 to the minus 12, giga is 10 to the 9, nano is 10 to the minus 9, and so on. And you know now what the derived units are. And with that, we close this objective, and we still have 4 more to go, but I'm gonna save those 4 for additional videos. So as always, if you don't feel 100% sure about this concept here, then review the textbook again, go to the tutorial videos that are posted, post a question in the Q&A in Canvas, or send me an email, or go to the Science Learning Center, whatever you need to do. And you can use the Science Learning Center online also, so make sure that you check their website. So until the next one, see you later. Bye-bye.